Good morning, good afternoon, and good evening. This is Prithpal Bogil. I'm part of the Apigee/Google Cloud product management team, and we're really excited to have you join us to have yet another go at one of the webinars on microservices. So today we are going to be talking about how do you really manage the complexity of microservices deployments, what kind of platforms do you actually run microservices on, and more importantly, how you can leverage some of the constructs from API management to make for an awesome developer experience. As part of this webinar, we may be discussing about some futures. Again, the disclaimer highlights that please make any kind of purchasing decisions that you would based on currently generally available features. So a little bit about myself, Prithpal Bogil. I'm part of the product management team at Apigee/Google Cloud, and I drive initiatives around our ecosystems, of which Pivotal Cloud Foundry is a huge part of it, along with doing some on-premises and API monitoring solutions. Been with Apigee for about 3 years, super excited to kind of be here, and I'm joined by my cohort for today, Kenny. Kenny, quick intro.
I'm a Spring developer advocate at Pivotal. I'm also the author of Cloud Native Java, which is about building microservices and cloud native applications using Spring Boot, Spring Cloud, and Cloud Foundry.
Excellent. Thanks, Kenny. So let me quickly walk through the agenda and also discuss some housekeeping things. So we're going to be spending a good part of the time talking about, this whole thing about, hey, how do I really convert from monolith to microservices? How does the journey look like? What are some do's and don'ts? Then we're going to get into how microservices are essentially exposed outside the departmental or enterprise boundaries as APIs and why API management becomes so important in that mix. Then we're going to focus a little bit on the relationship and partnership that Apigee and Pivotal Cloud Foundry have had for a few, walk you through some of the integration we built in, discuss some customer benefits and why you should care. And then lastly, we'll be making a call to action with certain specific guidelines around how you can get started. And as part of the webinar, you are able to plug in your questions on the Q&A panel on the left-hand side. And without further ado, I'm going to turn it over to my cohort, Kenny.
Thank you, Prithpal. Okay, so we're going to start out by talking about architecture. And so when we talk about microservices, we really should examine why we're going to microservices from our monolithic applications. So starting with the monolith, now here in this diagram, which we started with a monolithic application on the way to microservices, we have something that might look pretty familiar. So in the center here, I have an application server. I have Apache Tomcat. Now in the center of that, I have a deployment artifact, a war deployment. Now inside of that war deployment, I have multiple components. I have the storefront UI, accounting service, inventory service, and the shipping service. Now a key problem with monolithic applications is that if I make a single line of code change to this app, I have to deploy everything all at once to production. Now this causes other problems that are cultural as well. The first of which is going to slow our velocity getting into production. So if I have many different teams who are all working on the same application at the same time, then all of these changes need to be coordinated, right? So if you're sharing a deployment pipeline to go to production, it's kind of like taking public transportation to your production environment. Now this is going to slow us down. Right, so we have to coordinate more. We have to worry about stepping on each other's toes. We have to worry about things like integration testing between our components, and this is really going to slow our velocity. It also takes too long to ramp up new engineers, so it's not so simple just to add new engineers to a project to go faster. Now, if you have a million lines of code, a new engineer is going to have a lot of catching up to do to understand how to safely change an application. And at some point, the code base is really just too large for any one person to fully comprehend. Now, you may have experts who have been there from the very beginning, experts on the code base, and maybe they designed the original application, and maybe they're very productive developers. But what ends up happening is that these senior developers, many years later, are just telling the history of the code base. They're ramping up new engineers to get them to be effective to safely make changes on a project. And that's really going to tax their time. We also have these two opposing forces when we develop monolithic applications. First of which is that we're going to have our developers who are tasked with creating change. they're going to be able to create changes in their applications, and then they want to push them to production. But we have these other opposing forces, which is our DBAs and our ops. Now, they're going to fight back and resist changes because these flood of changes need to be vetted to make sure that they're not going to bring down the application. Now, for DBAs, we might have a shared database in the back end, a MySQL database in this case, where our DBAs are making sure that the different components and the different teams who are making changes to a schema aren't going to cause an outage for other components. Now, we also have operational problems with monoliths. We're going to have to coordinate a lot more. So each of our teams, we might have a product manager, and a product manager is going to want to get in a set of features into production. Now, in order to get all these features into production, there's going to need to be a lot of negotiation between these separate teams on which change makes it into the next release, and that's going to slow things down. Also, our operations team is going to drive the runtime environment of our application. So if our developers want to use new tools that make them more productive to help them go faster, they're going to have to go through the ops team. Now, with tools like Docker or using containers in general, a developer can define what their runtime environment looks like. And so they'll be able to manage themselves any dependencies they want to upgrade in their container that's going to be deployed to production. So our operators are going to take on the full operational responsibility of the applications, including VM upgrades. Their primary responsibility, though, is to make sure that things stay online. And that's going to be very difficult if there's competing interests to change or upgrade virtual machines. But more than anything, it's this. You have to deploy everything at once or nothing at all. And that's why this model breaks down at scale. And then we move towards the service-oriented architecture, or SOA, and we got a little bit better. So instead of one large deployment, we've split out our deployment into 3 separate artifacts here. I have an accounting service, an inventory service, and a shipping service, and those are all being managed by one service team. Now, the problem with the SOA is that as it grows, there are shared libraries which are going to impede progress. Now, at the very bottom, I have the domain language, the domain objects that these services are going to exchange to implement certain features. Now, down at the very bottom, I have a customer record and an account record. Now, if I make a change to those records, then it's fine that I just deploy the accounting service. But if I make a change to the address record, then I have to deploy all 3 of these services at the same time in a coordinated release. And what could end up happening is there might be a defect, and that's going to require me to coordinate also a rollback of all 3 of these services. And so as I add more services, I'm going to have more complex deployments. So now we've arrived at microservices, and it helps us get a lot better at some of the problems that we had with SOA, such as shared libraries. Now with microservices, we're going to have a set of small teams who are organized around business capabilities, who are all independently working on or building their applications and running them in production. Now the key here is that we're going to increase the number of pathways it changes into a production environment. Now each one of these applications are going to be very small, easy to reason about. If I add a new engineer to a microservice team, they should be able to reason about the code base and safely make changes within about a day. Now each one of these applications are going to be independently deployable, meaning that each one of my teams is going to be able to add features to the production environment without having to worry about constant competing interests or having to worry about taking a public transportation to production. Now, how this is all going to work is that our teams are going to produce and consume APIs. So to implement functionality, if I'm in one microservice, I'll have the ability to use APIs produced by other microservices to implement a certain feature. Now, as a part of that, I'm producing an API as well. And so you have this give and take relationship with other microservice teams that allow you to scale this model effectively. And then finally, teams can choose the best tool for the job. Now, in this example, I have a movie use case where I have a rating service and a user service. And you can see there's a lot of yellow in this diagram. There's a lot more databases. So if I'm a development team who needs to use, let's say, Neo4j, which is a graph database, because I want to do PageRank recommendations for movies, I can go ahead and choose that technology. I'm not going to be constrained to use one shared MySQL database. Now, I put together a reference architecture which explains how front-end developers are going to be able to communicate with back-end microservices. Now, in this example, I have an online store, and I have a collection of 5 microservices here: the catalog service, the account service, inventory, and the shopping cart service, and the order service. And you can see that each one of these services has their own database. Now, if I want to expose these 5 services to a front-end developer who's working on the user interface of the application, that developer shouldn't have to worry about where these services are located. Now, in the case of Netflix, who has over 500 different microservices, to develop an application from the front end on top of that many services is going to be very difficult and complex for the front end developers. Now, I could go from my front end application, which is purple here, the online store web, which is a Spring Boot app. I can go from that application directly to each one of these microservices. But having to worry about the complexity and the sprawl of all of these different applications and their APIs, that's going to require front-end developers to know a lot more about the domain of the application instead of just having a seamless monolithic API that they can work against. And so we don't want to do these direct connections between these microservices. They're very brittle and are hard to manage. Now, what we can do instead is we can use something called an API gateway. Now, in the middle here, what I have are backing services or platform services. So I can use a cloud platform like Pivotal Cloud Foundry to be able to provision services for my application deployments. I can bind to those services, and they're going to give me a set of features out of the box that helps me manage all this complexity. Now, to be able to communicate with my backend services here from the front end, I can go through that API gateway. I can specify a certain route. For instance, if I want to communicate with the catalog service, I can use /catalog. If I want to communicate with the inventory service, I can use /inventory. Now, this gives developers on the front end an easy way to reason about those backend APIs. At the end of the day, they're just routes. And the API gateway is going to handle proxying in or providing back responses from those services. Now, I have other services here as well, like Discovery Service and Configuration Server, as well as a user service. Now, with Pivotal Cloud Foundry, you can provision a lot more than just an API gateway. You can provision these other services that help you solve these cross-cutting concerns when you're creating a microservice architecture. Now, the next question that I usually get asked when I talk about these kinds of greenfield applications is, how do I start to split apart or create microservices from a monolithic application? So here in this example, I have a customer service, which used to be just one large monolithic application. Now, the first step here is I want to take out all of my stateless components, which are going to be my front-end components, and create them as a stateless application. Now, that's going to be the first step. So split out the user interface. So you can see to the left here, I have an online banking application. Now, what I've done is I've just refactored that front end from the customer service into a new application. And what I'll do is I'll use Pivotal Cloud Foundry, my cloud platform, to easily self-service and create that application deployment, and then bind to other services like a discovery service or a configuration server. Now, the next step is I want to start reasoning about what other components that do have state that I can split out and create as separate microservices. And this approach is called splitting the monolith. Now, the first thing I want to do is I want to look at my backend, and I want to look at my database schema, because that's where everything started, and that's where the complexity is going to be. And so looking at the schema, I might see foreign key relationships between these different tables, the account, customer, and user records. Now, I can choose which one of these tables will be best suited to be pulled out and refactored into a new microservice application. Now, in this example, I chose to extract out to migrate the user table, which used to be in the customer DB, into a new MySQL database called the user DB. And then I need to refactor out the functionality from the customer service that handled user authentication, and now create a new application called the user service, where that new functionality, or the old functionality, is going to be refactored too. Now, to do this, what I'll do is I'll stub out the service methods of the customer service that handled user authentication, and then I'll forward them over to the user service. So what I'll do is I'll be able to easily manage the abstraction around all of the dependencies inside the customer service application just by modifying the user class, the user service class, and then just redirect all those calls to the user service instead of handling them inside the process. Now, this is a very complex thing to do. Not all companies succeed at this approach because there are things you have to worry about in the back end, like foreign key relationships. It's not so easy just to refactor out a user table into a new database. And so there are other methods as well, such as strangling the application, which means that you'll build microservices around your monolith, and you'll slowly over time extract data and put them into new system of records. Now, before I turn it back over to Prithpal, let's talk a little bit about Pivotal Cloud Foundry. So Pivotal Cloud Foundry helps your teams focus on the activities that drive business value. You'll be able to let Pivotal Cloud Foundry handle just your infrastructure concerns, things like OS patching, container orchestration. And you'll use the platform's built-in tools for concerns like scaling, metrics, microservice patterns, and especially API management. The idea here is just to focus on creating great custom applications and just let the platform handle the rest. So now I'm going to turn it back over to Prithpal to talk about how Pivotal Cloud Foundry and Apigee work together to help simplify API management for your microservices. Prithpal.
Hey, thanks, Kenny. We actually have a couple of questions for you which just came up. Let me just kind of run them by you. I just want to pick your thoughts on that. And I think this is a question that I see asked pretty often. So the first question for you is, in your experience, how do your customers, approach the whole microservices development piece today? I mean, is it just being big bang? Do they completely refactor everything? Do they pick certain things piecemeal? I mean, what's been your experience? What are you seeing?
There are two patterns which a lot of companies use, and each company is unique. Now, there's that splitting the monolith approach, which is very difficult and complex to do if you have things like a data warehouse, which most companies do, because you have all of these back-end components that really make it difficult to just refactor functionality from one application and create that in a new application. So if that doesn't really work well for your application and your data warehouse, then you can take another approach, which is to create greenfield microservices on top of your monolithic application. And you can use an edge around that monolith, and you can use that as an API. And then over time, you can just pull data out and remove that dependency on the back end from the monolith. And you'll begin to just refactor out functionality just by creating new microservices. And that works very well.
Excellent. Thanks, Kenny. There's another one which one of the audience members has asked, so I'm going to read it out to you. The question is, why do I really need a cloud-native platform like Pivotal Cloud Foundry for deploying microservices? Can I not deploy them myself using some tools that I can grab, build? I mean, any thoughts on that?
Yeah. So the big problem with doing everything yourself is that it's going to take a lot of time. Now, you can kind of look at your competitor if they have a cloud platform which has built-in automation, things like metrics, all these things that you're going to need to piecemeal together and create on your own, build it yourself. That's going to take a lot of time just to build business value, right? So what Pivotal Cloud Foundry focuses on is minimizing the time to business value. And so what you want to focus on is just building your applications, just building out that business logic, which adds value to the business. And you can let something like a cloud platform manage the rest. It also gives your developers the ability to self-service. So you don't have an ops team who's just responding to tickets. If a developer wants to upgrade a virtual machine, they're going to be able to build their application and run it in production. And that's key, and that helps companies go much faster.
Excellent. Thanks, Kenny. I think that was super helpful, both for the audience and for myself as well. All right, so let's kind of switch over and talk about, why API management and, what's the importance and relevance, more importantly, of this when we start talking about microservices. So our view is that, the moment you start building some useful capabilities with microservices, pretty soon for that microservice to be useful, you have to share it either across a departmental boundary, or across or outside of the enterprise boundary. And the reason for that could be perhaps you're powering internal apps through your microservices, or in some cases, you're extending those capabilities out to your partners and to a public ecosystem which can leverage all those microservices. Today, in our view and in our experience, we have seen customers follow a standards-based approach using an API, or short for Application Programming Interface, as the contract by which that microservice get exposed either across the different departmental boundaries or across your enterprise boundary. So that kind of becomes as the contract to be able to expose that capability such that any other app developer who's trying to build something useful, whether that's an internal app developer or an external app developer, can use that specific microservice. You may think, well, what are some of the other reasons I should be using an API layer on top of a microservices? Well, one of the most important ones which comes up is that around abstraction, that around insulation. And what we really mean by that is what kind of microservices are being built in the platform. Really, the customers shouldn't really care about any kind of inherent complexity in that microservice. What we have seen customers do today is they use some very standards-based API design docs such as OpenAPI or Swagger, as it used to be known earlier, and they highlight that this is how this ordering API should be, and underneath the order API layer, it's actually powered by the microservice. So APIs provide that shield, if you would, where it lets developers who are responsible for building out some of those capabilities as microservices can continue to do that at the same time without impacting how consumers get access to those capabilities. So that becomes a very, very important piece in the whole mix. The other trend that we are seeing, which is emerging out there is, well, how do you really enable easy consumption of those microservices? So REST is a pretty popular standard, which is actually a preferred way of accessing many of those APIs. Obviously, you have many other standards which are also evolving, but REST has some unique properties, such as it is very quickly able to surface some clean, easy to understand APIs. That is very important. At the end of the day, there's no point building microservices if in an upstream way they cannot be adopted, right? The whole purpose of driving agility using microservices is to ensure that they can be rapidly adopted by app developers who can start building some apps and extend the value of the ecosystem. The other aspect around REST is it also enables independent deployment. It is agnostic, which means it doesn't really matter what language you are writing your specific microservice in. As we know, the cloud world today is all about containers and polyglot. REST APIs actually provide that abstraction, that bridge, for you to be able to easily expose all your microservices capabilities, no matter what programming language you author them in, and let them scale very, very rapidly using some cloud-native platforms. Now you can imagine, as you start migrating towards or transition towards building or decomposing your monoliths into microservices, as Kenny mentioned earlier, you saw how a monolith kind of got split up into small, discrete components. Well, the reality is, suddenly you're going to see a sprawl of microservices, many of them which are going to be exposed as APIs. The singular most important thing at that point is, great, I have so many microservices which are exposed as APIs. Can I discover and reuse them, right? How do I avoid the problem of many microservices being out there and consumers or even API developers who are building those microservices not knowing if one exists and risk duplication of effort? As the microservice journey continues, it becomes even more important to be able to ensure that there are consistent security standards. So what do I mean by that? So let's say you decompose a monolith into many different microservices. Well, you want to ensure that there's standard OAuth-based security standards enforced across all those microservices. You want to ensure that you have the right kind of protection from a traffic management perspective, but also more importantly, from a threat protection perspective. SQL injection, core, the different kinds of cyber threats which are out there challenging, how the microservices evolve, right? So you want to ensure that there's good amount of security built into it. The last one is flying blind. What we really mean by that is many times it's great that you have microservices, it's great that you have folks using them, but you need to be able to very quickly figure out who's driving adoption to those microservices, right? Does the business have the right kind of visibility into the value that is being generated from the microservices? Are they able to answer questions around, well, how many orders have been placed for the order service, so on and so forth? In our view, just the microservices stack by itself doesn't offer those important capabilities, and hence microservices will fail if you don't have the right kind of API management around it. Okay, so what does Apigee API platform bring to the mix? Apigee API platform is a purpose-built API platform which is scalable, which is highly available, and which enforces API consumption in a big way. So the Apigee API platform is available as a Apigee managed SaaS offering for our customers. We started a journey on AWS. We still continue to have our SaaS offering on AWS. But we are a Google company now, so as you can imagine, we've now started making the Apigee SaaS offering available on Google Cloud as well. You can either use Apigee in the cloud, or we have customers such as telcos and financial services customers who can deploy that completely on premises. So one of the architecture principles behind the Apigee platform is the ability for it to be either use it as a SaaS offering in the cloud, or we ship the exact same software bits to our customers so they can deploy it on premises. From a deployment perspective, you also can federate out different gateways. So as an example, we have an enterprise gateway which can be used completely in the cloud or on premises, which is ideal for some high-end, API management use cases such as soup to nuts, transformation, mediation, traffic management, security, having support for a bunch of different kinds of policies for security, such as OAuth, SAML, etc. And we also have another shaped gateway called a micro gateway, which is very ideal for microservices-based API management. So Apigee is a comprehensive API management platform, which means not only does it give you all the capabilities to start securing and protecting and giving you the right kind of visibility into your microservices today, it has all the capabilities as our customers start building API programs, they encounter specific features which are required as they go from an internal API program to an external API program, where they need to be able to provide a developer portal. So all the app developers who are to use the APIs and microservices can do that through a developer portal in a self-service way. It has capabilities for analytics, so you can get the right visibility out of the box, and capabilities around monetization. So this API management platform, Apigee, is truly meant to provide capabilities for the full API lifecycle. That means right from design and developing the API to securing and publishing them, but as your API program starts to pick up, you also have the tools in the platform to be able to monetize your APIs, especially when you are set up as a shared services component within your organization, or you're trying to monetize your APIs externally, which many of our customers do today. So essentially, Apigee provides the API layer for microservices. We looked at two different kind of gateways. The first is the enterprise gateway, which has a list of comprehensive set of policies to protect all your APIs, and then we have a micro gateway which provides traffic management, security, and analytics for microservices, as we have seen. Can you talk about some of the different microservices? You can leverage the Apigee micro gateway to provide API management for those. All right, so we've spoken a lot about how microservices are built, how you decompose monoliths into microservices. Can you also discuss some of the benefits of taking that approach? He also mentioned around Pivotal Cloud Foundry and what that cloud native platform brings to bear for the app developers and operators. Let's now talk a little bit about how, when customers start to transition from microservices, from monoliths to microservices, API management starts to kind of become a key part of that abstraction. So in this example, in this slide, you can see examples of many of our customers who are on the microservices journey, right? And the reality is that they still continue to have certain capabilities which are going to reside within the monoliths. They're not going to disappear overnight, or everything is not going to be moved over to microservices tomorrow. As you transition to microservices, API management becomes a very important piece of your stack to be able to provide you that installation, to be able to ensure that as you're moving slowly from monolith to microservices, that it can give you that protection, the insulation, so that your consumers on the left-hand side aren't affected, so that all your microservices continue to be secure, you have the right visibility, and they're exposed as APIs which developers can adopt quickly. Awesome. So what are Apigee and Pivotal doing together? In fact, Apigee and Pivotal have partnered for a long time. Right about a couple of years back, we had introduced our first integration, which was leveraging the route services mechanism within Pivotal Cloud Foundry. I'll talk a little bit about that shortly. We finally then added support for Edge Micro Gateway over time, and we also have recently released BOSH installs for Apigee Edge. So for those who may have caught Kenny's slide earlier, BOSH is the management and monitoring tool that is used to install, deploy, manage, heal Cloud Foundry. In a similar way, for customers who want to deploy Apigee Edge on premises, we have BOSH installer, so you can install, deploy, manage, heal, and maintain Apigee Edge through BOSH the same way BOSH does it today for Pivotal Cloud Foundry. So let's talk a little bit about the different integration options that our customers have today. So we have two flavors of integration. The first one is through route services, in which case you can use the Apigee Edge Enterprise Gateway. So as an example, you deploy a tile from PivNet, which is the Pivotal Marketplace. If you're a Pivotal customer, you can deploy a tile into your Cloud Foundry instance. Once you install that, it essentially deploys a service broker. So service broker is a component of the architecture which lets Pivotal Cloud Foundry apps communicate with services either within the Cloud Foundry deployment or which are external to it. So as part of this integration, you deploy a service broker, you configure the right service plans. Once you do that, the moment a Cloud Foundry app developer pushes a CF app, deploys it, you can use the route services component to automatically issue one command, and by doing that, Apigee Edge platform automatically creates a API proxy for that specific Cloud Foundry app and integrates that into the routing logic, which means when you do that, when you call the Cloud Foundry app now, it is now protected through an API management layer just using a couple of clicks. The second integration through route services that we have delivered is leveraging the Apigee Edge Micro Gateway. So what that means is, in the first integration, Apigee Edge could be in the cloud. In the second integration, you can have Apigee Edge in the cloud, but you can actually deploy Apigee Edge Micro Gateway, which is a very small, footprint that can be deployed as a Cloud Foundry app natively, and it still uses a route services-based integration to provide you API management capabilities using the Micro Gateway. And some of the use cases which come up around this are, especially the ones which have low latency requirements. This kind of integration style is fairly popular. The third one that we're seeing, which is coming up quite a bit, and many of our joint customers are asking for it, is the Cloud Foundry Build Pack. So this meta build pack approach essentially takes the Edge Micro Gateway and injects that into the app container. So instead of having any kind of routing overhead, the API management layer is kind of injected and sealed into the app container. So as the apps get deployed, they are secured at source. Today, this kind of integration is available as an open source project, but we are actively working on making that available as a productized integration just like the other two are available today. Okay, so these are the three primary integration options available to our customers today. So let's quickly recap some of the benefits for the developers and operators. And out here, I'm referring to the Cloud Foundry developers and the Cloud Foundry operators. The underlying idea is by building these specific integrations, we are able to accelerate app modernization for developers, which means many of the cross-cutting concerns that they have to worry about otherwise, such as enabling OAuth security for all the microservices, such as being able to provide any kind of traffic management threat protection, right? All of them can be automatically inserted as part of the integration that we have provided. On the operator side, the integration that we built really helped ease operational concerns. So while the developers are more focused on rolling out capabilities very, very quickly using microservices and APIs, operators are more focused on ensuring that all of them are exposed in a secure way and that they have the right visibility into the usage and performance of the APIs. Using these integrations, we are able to expose and support three different kinds of use cases that we see commonly in our joint customer base. So the first one is around microservices development. Out here, the key component is the integration that we built and the Apigee Edge micro gateway, where you can essentially use either the Cloud Foundry Meta Build Pack deployment option, or you can use the route services based Edge micro gateway pattern to be able to enable protection and access control to microservices. The second one is that around app modernization. We actually see this thing quite a bit. And this is very similar to the slide that I showed you. As customers are transitioning into microservices and they're modernizing their apps, they need to be able to ensure consistent, secure APIs surface to the consumers. They need to be able to ensure that you have a developer portal which can be used by the app developers to access those APIs, which are powered by microservices. So that's the second use case. And the third one is around enabling ecosystems. As you mature your API program, as you evolve with those capabilities, pretty soon you've seen customers who start extending their ecosystem into a public kind of a setting, right, or a partner API program, in which case you need to have the right tools such as Apigee Edge and Pivotal Cloud Foundry, and especially the integrations, to be able to allow the APIs to be discovered by different kinds of consumers, app developers, and build a lively ecosystem of apps. All right, so essentially, what does all of this lead to? Well, we feel that all of this leads into powering what we call as the digital value chain. The digital value chain is essentially taking an outside-in or a digital consumer view into the capabilities. In this case, you have a user who essentially accesses an app which are built by an app developer. App developer uses the APIs which are powered by the Apigee Edge platform, and APIs power some of the microservices which can be built using Cloud Foundry. So Cloud Foundry helps you reduce the time it takes to build software, and then Apigee Edge reduces the time, enable the consumption of APIs, and help all the APIs deliver the connected experiences through apps that users care about. All right, so let me make a quick call to action, and then we will review some of the questions which may have come up in the meantime. So the three asks of the audience who are listening and watching us today. If you happen to be a PCF developer or an operator, you can learn a lot about the integration that we built in, the Apigee Edge Service Broker, the Edge Micro Gateway. There are links in this presentation which we'll be sharing. To make it even more easy for Pivotal Cloud Foundry customers to be able to adopt Apigee Edge, we actually have a free microservices starter kit offer. So feel free to ping your PCF rep about what that offer is all about, and or have your PCF rep introduce you to a member of the Apigee sales team. If you're new to Apigee Edge, we have free trial, free sign up for trial account, which means you can go to apigee.com and set up for a free Apigee Edge account today, now. And once you do that, you can learn about all the cool things you can do with Apigee Edge. There are a bunch of tutorials. You also have a community site, community.apigee.com, where you have a lot of different assets around different kinds of things to build API proxies, all the way to using all kinds of policies. And then you can also check out the documentation on the integration that we just went through on the site as well. And if you're new to Pivotal, again, visit pivotal.io to learn how you can build apps, how you deploy software using cloud-native techniques, and you can ask the Apigee rep to be able to introduce you to the Pivotal rep. So I think that's pretty much what we had for the webinar. I'm going to bring up the Q&A panel and see if you can answer a couple of questions here. Okay, so there's one question. Kenny, I think this one is for you. The question is, what is the performance impact as we migrate from monolith to microservices architecture?
Yeah, so performance is going to be a key concern because you're going to be, you want to mute your microphone? Performance is going to be a key concern because instead of being able to communicate with other components in process, you're going to need to contact other applications over the network. And so you're going to incur latency for each hop. Now, going from one service to another might be a negligible amount of latency. But if you have call chains that maybe are 3 or 4 services long, that's going to be a concern. So you want to make sure that you use techniques like caching. If you do have these long call chains, and to even figure out what that looks like, you can use tools like Spring Cloud Sleuth, or which wraps around Zipkin from Open Tracing, which allows you to do distributed tracing that maps out the latency and the calls between all of your services. And then from there, you can figure out how to prune down these connections and also adding caching to increase performance.
Excellent. Thanks, Kenny. There's another question which I think I can answer. The question is it possible to have a reactive user interface through the API gateway? So I think the short answer is yes, you can use the API gateway to render some kind of reactive UI, although that wouldn't be the main use case for that purpose. So as an example, you have the API gateway, which, so as an example, the Apigee platform provides you a full-blown OAuth server, which is part of the platform. As part of the OAuth dance, usually customers may render a specific UI page to enable logging in a specific user into the app, in which case you can certainly do that through the API gateway. It has all the capabilities for you to stick and return HTML. That being said, it's an API gateway, right? The core purpose of the platform is to be able to protect APIs, surface them as clean APIs which can be accessed. So I wouldn't try to use that as a UI rendering tool, but more so as an API gateway to protect your APIs. In some limited cases, you can certainly add some UI which can be rendered through HTTP to consumers. Okay, let me see. There's another example. There's another question. Okay, for Kenny, it says, do you suggest implementing a CQRS framework such as eventuate.io to support the decomposition from monolith to microservice? Can you take that, Kenny?
Yeah. So event-driven microservices are going to be a different concern. Now, it depends on what your domain looks like. My recommendation is always to go event first. And what we're seeing is that the transition from monolith to microservices, if you didn't already go with an event first model, then it's really tough to go from regular microservice to event-driven microservice. And so things like CQRS, event sourcing should really be looked at to support whatever requirements you have for your application. And I think Eventuate is absolutely a great example. And so I do recommend taking a look at it. There are other platforms that allow you to kind of roll your own features, but Eventuate is a good tool.
Okay, excellent. I think there's another question. I think this is for me. I'll take that. The question is, what differentiates Apigee Edge from other API gateways such as Camel? That's a question which actually comes up quite a bit. So we feel there's a fundamental difference between what an API gateway and an API platform can do. So as you saw, hopefully in the previous slides, API gateway is an important component of the API platform and is responsible for ensuring that all the APIs are secured, all the APIs have the right level of traffic management, throttling, rate limiting, etc. Sometimes mediation as well, right? So think mediation, think messaging at some level. Well, as we have seen, and hopefully you guys have observed that the API management platform uses the API gateway as a component of the stack, but introduces some very important components such as, great, I have APIs and I've exposed them. How exactly do I get these APIs in the hands of app developers? So at the end of the day, if there are APIs and they're not adopted, it doesn't matter how many APIs you've built, right? So the developer portal component of the API platform enables those APIs in a clean, consumable way. You can access API documentation of the developer portal. You can get access to the APIs with the developer portal. So it cuts down the friction for all the app developers. Number two, the API platform provides some rich analytics, which are not only limited to how my APIs are performing in terms of response time or my latency perhaps, but more so around, well, what kind of adoption am I seeing in my APIs across different partners? You can also build custom reports from the platform, which can help answer questions for your business, such as, great, we now launched an order API. Can you give me a breakdown of how many orders am I getting through the order API in a month across different regions? The last one is, as you start to mature in your API program, if you want to monetize your APIs, you want to be able to create different rate plans to access APIs, whether they could be volume-based or flat fee-based. All those capabilities require monetization built into the platform. So hopefully that kind of gives you a sense of how an API gateway differs from an API platform. Okay, I think we have one more question out here. I think I'll take that. The question is, can we use Apigee as a service orchestration or composition layer? It's a multi-part question. And the second part of the question is it rule, config-based, or custom implementation? Okay, so let me take a crack at answering those two parts of the question. So the first part is, yes, you can use Apigee as a service orchestration and a composition layer. It has capabilities to do mediation. You can do transformation. You can orchestrate. You can call out different services before you finally call a backend API. You can merge and compose responses and do mashups across different APIs. So all of those use cases, Apigee does a good job of kind of implementing those kind of capabilities. That being said, there's a difference between an API management platform and a middleware solution like an ESB. So if you have any heavyweight integration, which is doing some transformation in bulk for big formats, one big format to the other, I would push that down to your ESB layer, or if there's any kind of a process-oriented workflow, a process management tool is a great middleware solution for that. Then you are exposing them as clean APIs, which you want to rapidly expose to developers and be able to kind of provide all the protection. You can use the Apigee API management platform. And many times we actually see that the Apigee API platform is complementary to an ESB, where ESB can be your integration solution. That can be the solution which does heavy process-based orchestration, potentially service virtualizing access to some legacy systems. And then the API platform sits on the top, rapidly enables shaping up those APIs in the way that they need to be consumed and providing you all the benefits that we discussed around developer management, monitoring, monetization, and analytics. Okay. The second part of the question, I guess, out there is, is the platform rule or config based or custom implementation? So Apigee Edge is built on certain architecture principles. One of them is API first, which means we have an API to access all capabilities of the platform. And the second principle is extensibility. So Apigee Edge provides 30 plus out-of-the-box policies to be able to do things such as traffic management, caching, security, whether it's through OAuth, SAML, transformation mediation. But the one big attribute of the platform is extensibility. So in a self-service way, API developers can actually use a platform to author any policy that they want in JavaScript, Node.js, Python, and Java. So you really can use multiple languages to extend the platform and implement your own things. Okay, so I think that's about the time we have for all the questions today. Some of the questions which we weren't able to answer, we shall be doing that as we go along through the list. But we really appreciate you guys taking the time to join the webinar. Hope it was useful, and by the end of the week, you should see an email which will contain the link to the presentation, the recording, and also the presentation. So really appreciate you guys taking your time. Kenny, thank you for your participation, and we'll see you guys soon.